IBM S390. I don't know how many people here are familiar with the S390 or the IBM mainframe. Okay, there's a small bunch up there. How many people are familiar with Linux? Okay. How many people are not familiar with Linux or mainframe? Okay. Good. I'm going to do about 25 years of computing history in about 25 minutes. If you start with something basically simple like a CPU, right, a central processing unit, it consists of registers and it uses a bus to talk to memory, picks up an argument, does something with it, presumably intelligent, stores it somewhere else, okay? That's what an Intel processor does, it's what an S390 does, it's what your Motorola does, or Alpha, or PowerPC, or MIPS, or MIPSL, or whatever, okay? So what the people in the Hercules project have done is they have said, why don't we build an S390 interpreter, okay? So we're going to take an S390 instruction, pull it to pieces and say, oh, that's a register, and what do we do with these two? We add them, that's okay, and then we take the result and we store it there, right? So this is just a C program running in user space, picking up word for word, pulling it to pieces, doing whatever it says to do, and storing the results, and that's it, okay? Theoretically, a relatively simple thing to do. When you actually run the program, you'll come up with a whole bunch of registers and possibly a whole bunch of devices. And what you're seeing here is an emulation of an IBM S390 processor, okay? We go back to history. The IBM started off with the 360, they went to the 370, they're at the 390 at the moment, and going towards, well, they've released it, is the 64-bit version, which also runs on my laptop. Okay. What you have is a very, very old, venerable, successful architecture, which is very, very flexible. And that's the result, that is the basis of their commercial success. They've always been able to build onto it and to add it to, make it become something bigger based on what it was in the past. Okay? In December of 1999, IBM announced that there was a Linux for 390. Okay, nobody knew that IBM was doing this. Various people had been working on it before, particularly a guy called Linas, L-I-N-A-S. They've been working what we call the Bigfoot port. It was aimed at the 370 architecture, or a generic 390. And they got to the stage where it would boot a kernel and sort of halfway get into its first shell, at which point it panicked. But that was pretty good hacking for the time. Then IBM came out on early 20s, in December 99, and said, okay, we've done it, here it is. Here's the code, and go to it. So a lot of people started hacking Linux on S390. Well, the problem is there aren't enough S390s to go around. So at this point, people decided, well, why don't we take the Hercules thing, which is done as a sort of academic exercise, can we emulate this processor? Why don't we combine that with the Linux 390 that IBM's just released? And what you have is a program that interprets another program and just boots it. It takes a while because it's working through instruction for instruction, and once it's finished its I/O wait here for the disks, you'll see it'll use a lot of CPU. In fact, everything it can take. Okay? But the result of this is that we will then have a Linux kernel, an S390 Linux kernel, running on an Intel user program. Okay? Now that takes a little bit of thinking about, particularly when you think about the networking stuff involved. So we'll have a quick look at this. Actually, this is just bluff, you know, it takes so long to boot, I needed something else to talk about. So we'll do a quick look at ifconfig. I have my Ethernet, which is perfectly standard, normal Ethernet. And then I have a tunnel-to-tunnel device. which you can do in the 2.2 or in the 2.4 kernel. In 2.4 kernels, they're natively there anyway. As far as the Linux on IBM is concerned, I have two devices called channel-to-channel adapters. Okay? Anybody here know Intel? Intel assembler? Okay. You're familiar with the concept of a port, as in out byte port or out port byte. I've forgotten the syntax. Okay? It's basically an I/O device. You can send a character to a printer. Okay? If you want to think of that in a 390 context, you would have to think of a channel, which is an I/O device, speaking to a CPU on the other end of that channel, and it becomes more like when you run two Intel boxes with SCSI to SCSI back to back. In other words, you have a very, very fast, high bandwidth connection between two CPUs. You can do TCP/IP over SCSI. Right? It works. It's very fast. Not that easy. Okay? So what we have on the IBM side is a channel talking to, it thinks it's talking to another mainframe on the other side that knows how to do real-world IP. Actually, it's talking to a thread in the Hercules program, which is doing its IP port. That's why I have the secondary address. Okay? In fact, it's already got. The system is, the channel-to-channel is already connected, and so we will have TCP/IP running between the two of those. Fairly shortly, you will see this line, or this block, which is my console, starting to scroll through, if I've done it correctly, showing all the system messages, because I've got the system log on the 390 system logging to my Intel box. Okay. That usually works really, really cool if I get time to set up the demonstration perfectly. Okay. I should be able to do a ping to the other half. It works. Fantastic. Okay. Therefore, I should be able to telnet to the other side. This works most of the time. Okay, it's not the fastest of all systems, but that's only because I'm sitting here on a 230 some odd megahertz PISY, right? It's fairly PISY quality. At work, I happen to have a dual Pentium box, which is running dual 800s. It's got 512 meg of memory. It's got lots and lots and lots of SCSI disks, and it will compile a kernel in under a day, which is okay. I think I probably have a network misconfiguration at that point. So to sum up that somewhat, in 99 we had the Bigfoot port, and University of Marist in Poughkeepsie in New York State, they set up the first Linux for 390 distribution that we had. And it was basically a mixture of tarballs and RPMs without a functioning RPM database. Okay? It was very, very much experimenter's work. It worked sometimes. There were parts that didn't work. But it was fun getting your hands dirty. Hercules has been an IBM 390 emulator for, what, 2 or 3 years now? It was started by a guy called Roger Bowler in England, primarily as an exercise to see if he could do it. Right now, it's a program which is, I find fascinating. It can run VM370. It can run today's OS 390. That's your MVS, right? Anybody know what MVS stands for? Don't tell me. Man versus system. Okay, it will run a mainframe operating system. It would take about an hour to boot OS 390 on this particular laptop. Other machines, if you have a bit more power, you can get it down to about 20 minutes, which isn't bad because in practice, in real day life, you're talking about quarter of an hour, 20 minutes to boot a real mainframe system. Okay, so we're getting fairly far. Early in January 2000, several of us had the idea to port Debian to 390, and a few of us actually had the skill to do it. I started in spring of last year with the brute force build daemon, which was basically just get any package we could find and throw it at the compiler and see how many pieces it came back in. We're now, if you remember that graph we saw before, where the Debian 390 curve just takes off this summer. That's where we had some guys that knew what they were doing, working on it. In May, June last year, I was invited, I went to Poughkeepsie in New York to write the Red Book for it. If anybody wants to take a look at I have a copy of it here. Okay, where do we stand today with Linux for 390 on mainframe? SUSE was the first to come out with a fully functional, working distribution of Linux 390. Very good distribution, well done, and hard work. Okay, Turbo Linux was the second that came up with it. So they're in the market. Red Hat is at the beta phase at the moment. They're in the process of going GA, that's general availability, but they're not there yet. Debian, as far as we're concerned, it works, it boots. We haven't done the installer stuff properly, so it's a lot of doing it by hand, right? Obviously, there's no such thing as Debian floppies. We don't have that, right? We don't have sound support. The only thing in mainframe we'd use a Sound Blaster for was if the floor were slightly uneven. Okay? There are some very, very competent people in South Korea, particularly the Parks, who run, they've set up their own distribution, which they call Kaiman. And they were the first people to start producing dead packages. I have trouble pronouncing their names. Okay, in the meantime, we have the 64-bit of IBM's processor family, the S390X, has hit the market. I have managed to boot a 64-bit Linux kernel on this particular laptop. It's not fast, it's not stable, but it's starting, right? This is very, very much, I think bleeding edge is the polite term. However, if you're onto a box that has a fair amount of power, either dual Pentium or Athlon, anything that's 4 digits and above, it becomes quite passable. Where are we now? There's a very, very good list server at Marist. If you're interested, just look for Linux 390 on Google or whatever your normal search engines are. There's a lot of people there, and it's interesting to see the way the people work across, through the various distributions. There's SUSE people there, there's Red Hat people there, there's Debian people there. Every so often the Turbo Linux guy comes up. Alan Cox is there. Very, very high quality stuff. There's very, very little flaming or the usual distribution wars. My distribution's better than your distribution. Part of the thing that's funny is that the mainframers, the old guys, the gray-haired guys like me, they've been into the idea of open source, or the reason why I see so far is because I'm standing on the shoulders of other people, right? They've been into this for a long time, and they have this thing they call the CBT tape, which is just a collection of free, as in freedom, free software that people have handed down from system programmer to system programmer because it solves an itch or it solves a problem. Gerhard Thon is a Debian developer, lives in Stuttgart, and also works for IBM. Has enough CPU power at work to sort of play with. He doesn't have to play with this kind of thing. He has, but he doesn't regularly. At the moment, the Debian build is running on a box on a Multiprice 3000 sponsored by Millinux. Now, Millinux, or the Millinux, depending on how you pronounce it, are the same people that wrote the ThinkBlue and the ThinkBlue 64 distribution of Linux 390. It's a software consulting house. The name Thomas Uhl will not be that unknown to people from Germany. He's in Linux Verband and groups like that. And in spite of the fact that they are actually producing a commercial, well, they're working commercially with Linux 390, and that's their daily job, they have decided to give us enough disk space and bandwidth that we can set up a build daemon for Debian and work as a direct competition, but it worked. Okay, where do we stand now? Debian 390 is in the process of being integrated with the rest of Debian. That's a non-trivial task. It's also a considerable amount of volume of messages to developers. Hey, you can't do that on 390, or are you even aware of the fact that there is now a 390 port? A lot of the people have made the assumption, I'm writing for Intel, and that's all there is. They've started to become aware of the fact that we also have, within Debian, 32-bit systems, 64-bit systems, little endian, big endian. So we're getting to the point where all these combinations and permutations of system architecture are becoming understood. Okay. If you want to see what's happening to packages, you can go to the latest build daemon. That's one more try. Pick one at random. Where we keep track of the individual packages as they come and go, and when and how they get compiled. Okay. Where are we going? We think we're aiming for Woody +1. That's being safe. We're trying to get to Woody. We're not sure if we will or not. Basically, we've got a lot of the base packages are done. What we have not done is the equivalent of boot floppies or a boot CD or a clean install mechanism. That's partly to do with the amount of description that we have to do to deal with the different forms of IBM hardware, of environments that they could be running in. See, Linux from 390 will run on bare metal. It'll run if you just put it on a CPU and say go. Nobody does that. The 390 processors can be chopped up into partitions called logical partitions. A lot of shops do that. And there's another step that you can take, and that's to put Linux onto VM. VM is virtual machine, and that gives you the opportunity of running literally thousands of Linux images on one machine. Okay? I think Dave Boyes ran 43,000 somewhat Linux images, working Linux images with Apache serving data. And the VM machine at one point just said, excuse me, I don't have enough memory to cope with another, whatever it is. So it was graceful degradation at that point. Okay, questions? Yes. Standard, the 390 ports or the 390 changes are posted as patches to a particular GCC. So we're running a GCC 295.4 at the moment. However, not all of the patches go up automatically into the upstream source stream. So we're at the stage, particularly with compiler, with GCC and binutils, we're at the stage where we, also with the kernel, where we have to take generic source, patch it with what IBM Developer Works has provided us, and then feed that in. That's not as clean as I would like it to be. One of the reasons is that IBM will tend to release, here's open source, isn't it wonderful? You can patch it against www.new.org. I love it. Right? So you have a problem finding out exactly which version of binutils or GCC or the kernel, with or without Alan Cox's patches, or was it a generic, or was it the Torvalds, or was Arcangeli doing? Right? That is what is slowing us down somewhat. Okay, questions? Okay, the 390 is not that fast a CPU. It's not the big number cruncher. What it is, though, is an I/O machine. Right? The 390 series gives you more I/O bandwidth than anything else I've ever seen. It just screams at large databases, right? So anything you're using a large amount of I/O in your subsystems, it's not the thing you want to do to set up a Pulvery farm, right? Intel's cheaper than that, cheaper for that kind of task. If all you're doing is integer and think, you're cheaper off with a cluster of, Beowulf type cluster. In terms of I/O, there's absolutely nothing to match it. In terms the bandwidth to the disks, they start at 17 megabyte a second, and go up. I haven't done it, no. However, you have several ways of doing network connectivity. One of them is to use a channel-to-channel to some box that does speak IP. The other is you can use I hate to say it, object code only module, which is a sort of closed shop proprietary black box binary that you can plug in and hope that it works, which will give you access to either your Ethernet or your token ring or your FDDI or your gigabit Ethernet, right? So you do have those options. Whatever you do in terms of IP chains of masquerading or other security things is the same as any Linux anywhere. It has nothing to do with the fact that it's running on 390. The I/O you're doing at that point is you're picking up basically packages off an interface, running some thinking, very little, and then just saying accept the package or drop it. So you won't find a massive performance increase there. Where you will find a massive performance increase is if you're using 390, for example, to run large databases, or to do anything that involves a lot of disk activity, large numbers of users, this kind of thing. Okay, I'm not saying that the 390 CPU is weak in terms of computation, but its I/O is the thing that is absolutely outstanding on that platform. Question? Okay, very good question. The question was, why would you use Linux 390 if you have a mainframe which is very good at doing large database things and you have DB2? DB2, if I'm not mistaken, is EBCDIC. Linux does ASCII. It's pure ASCII machine. So you don't have to sit there and translate each byte from one code table into the next code table and then pass out the answer. The other thing you can do is you've got your big DB2 RACF and security and Haftpflichtgesehen. You sit there as a Linux front end and say, let me take your transaction, thank you, and you just sit there and talk to the back end and say, hey mainframe, here's now the 1500 table lookups, would you do them for me? Okay? So you can use your Linux as an intelligent front end to all of your web clients, because we talk web, we talk net, we were born and bred on the net, right? And you use your back end mainframe to do the thing it's good at, which is thundering data, right? It just pumps data, which is what it's good for. That's what it can do. Question? How does Linux compare to OS 390 in terms of performance? As well as any other apples in any other pairs. They're completely different worlds. The OS 390 is a extremely complex system of subsystems. You would have a problem defining a workload but you'd have to choose an agnostic workload for both systems. Sorry? Hercules is released under the QPL. It's not GPL, it's QPL, but it is free software, yes. It also exists as an RPM, and it also exists as a Debian package. Of course. Yes. Slowly. But, okay, you can run anything that needs a 390 CPU under Hercules. Therefore, if you happen to be a mainframe programmer and you happen to have a Linux to play with, and you don't happen to have the opportunity of putting in a second sys res and second sys MVS system, you can do that. It's slow, but it works. Okay? You can also use it if you want to verify you're in the process of changing from 2.2 something to 2.4 something and you don't know if it'll boot correctly, or if after the last change in bin utils, whether or not you will survive that change. Run it on Hercules on your laptop. Okay, it works. No, because the channels are emulated. Hercules emulates devices. It emulates disks, readers, punch, channels. You might want to catch me on that later because it's a very, very difficult topic and I think we might lose a few people doing it. Okay? But what Hercules does is it emulates devices. Okay? I think at this point I am looking at a disk. It's a Dust D, it's got 50 cylinders. The guy upstairs thinks it's a swap partition. Right? Question?
Have you tried a Postgres database?
Postgres runs on Linux 390. Yes, I have not done it under Hercules, no. Oracle is not known to have produced an S390 port, no. Several people on the appropriate lists have said they find that a pity because they would like to see Oracle on S390. I haven't seen it. MySQL is there, Postgres is there. Right. I mean, we know that Oracle runs on Linux, Intel. So I don't think it would be very... Okay. Saying what? Okay. Last question. Does Linux support SNA? There is, sorry? It's Linux anywhere. Linux SNA, as I understand it, runs at the 802.any level, very, very specific to the device driver itself, which means either the Ethernet or the Tilting Ring frame driver. On the 390, we don't have access to that same level of device driver control. We're talking to an intelligent subsystem and saying, would you please put this package on the wire? So that subsystem knows how to do IEEE 802. Have to think about it, but not the LLC stuff that we need to do for SNA. So I think you would have to look at the Linux SNA mailing lists to find out how up-to-date JSHU list is. My experience hasn't been that hot. Okay, I understand I'm running out of time. I will meet anybody that's interested outside once I get out of the way here. And I thank you for your time and your interest. And a large thank you to the people of the networking troop that made something like this possible.